Okay, so something we did at the start of class was that we reviewed what linear, exponential, and quadratics look like given a table. So in a linear function, you either add or subtract to get from one term to the next in a table. For an exponential function, you multiply. Now, if it looks like division, it's because you're multiplying by a fraction, not that you're dividing. And last but not least is quadratic. So, like it was in the first lesson of this unit, quadratic is where you have a common second difference or a constant second difference. So what that means is if we look at this table and we see, all right, there is a 0 right here. So if I multiply anything times 0, all of these numbers in both directions should be 0. So because that 0 is present in the y values, that is not an exponential function. So the next thing we have to check is it linear? So how do you go from a 4 to a 1? You subtract 3. From a 1 to a 0, subtract 1. 0 to 1, add 1. 1 to 4 is add 3. 4 to 9 is add 5. And 9 to 16 is add 7. So there's not a constant difference in that first set of rate of changes. So now we have to look at the second difference and decide, is there a constant second difference? So how do you go from -3 to -1? You add 2. From -1 to +1, add 2. 1 to 3, add 2. 3 to 5, add 2. 5 to 7, add 2. So because it has the same second difference, we're adding 2 across the entire thing. That makes this a quadratic function. So now we have to graph it. So we go over to our table and we have our first ordered pair is -2, 4. So we're going to go -2, +4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and we cannot do 4, 16. So when you trace these dots to make our function, our line on this graph, you want to make sure that it is shaped like a U and not like a V, because that is a quadratic function. A V is an absolute value function, so if you make yours kind of V-shaped, you're not graphing the right type of function. So they all need to be shaped like the letter U. So where it says, what shape is this similar to? The letter U. And we call this a parabola. So we call these parabolas. So the shape of a quadratic function is called a parabola. So there's several characteristics of a parabola. So this relates back to the vocab sheet. If you were present in class, I gave you a filled in vocab sheet. If you were not present, you can look through the vocab and write it down if that's what you wish, because it is linked on Canvas, or you can wait till you come to class again and I will give you the filled in tip chart. So here's what parabolas have. According to our vocab sheet, a vertex is the turning point of the line or is the highest or lowest point. So our vertex here is this 1, -4. It's our turning point. So the y-intercept is something you guys have seen before. The y-intercept is where it crosses the y-axis, which is at 0, -3. The direction of this graph, because those arrows are pointing up, it opens towards all the positives. So we say this opens up. It's where it opens toward. The x-intercepts, again, something you've seen before. So where it intersects the x-axis. So that's at -1, 0 and 3, 0. So our next question is, does it have a maximum or a minimum? Maximum is the highest point. This goes up to infinity, so there is no highest point. Minimum, yes, it has a lowest point. Our lowest point on this graph is 1, -4 on this function, is 1, -4. Now the axis of symmetry is where would you fold this line in order to make two equal halves? So we have right along this line. So the equation for the axis of symmetry is that it passes through the x-axis at 1. You have to have that x equals because the axis of symmetry is an equation for a line that represents where if this was on a paper where you could fold it and the two halves would be the same. So x equals 1. The domain of this function, remember domains are the x values and range are the y values. There we go. So the y values. So the x values of this function, because it has those arrows on the left side, that means it goes to the left forever. To the left is all the negative numbers. So for our domain, we say -infinity. And then on the right side is an arrow. So that means it goes on forever. And to the right is all the positive numbers. So we say to positive infinity. So the range is just like your y values. So it's down and up. You always put your smaller values first in the range. So how low does it go? Well, there's our minimum. That's the lowest point. And since it's the y values, we look at that -4. So it stops going down at -4, so we use a hard bracket. And then it goes up to infinity. So we put the infinity symbol. So is it a function? Yes, it's a function. What kind of function? It's a quadratic because it's a U shape. It's a parabola. And is it discrete or is it continuous? Discrete means it's dotted. Continuous means the points that make up that function on a graph are connected. So it is continuous. And if you need a hint or a reminder, continuous means connected. So when it comes to the equation for a quadratic function, quadratics will always have an exponent of 2. So if it's a 2, it's a u. And the standard form for a quadratic function is y equals ax squared. So there's our exponent 2 plus bx plus c. That comes straight from the formula sheet. So if you know where your formula sheet is, make sure you're bringing it. If you don't know where it is, we'll get you a new one. But if it's a 2 in the exponent, it's a u, a parabola, a quadratic. So the rest of this paper is just more practice with those characteristics. So the vertex is the turning point. So on this one, our turning point is right there at -1, 4. The axis of symmetry is where you can fold it to make two equal halves. So it passes through the x-axis at -1, so your x equals -1 is the equation for the axis of symmetry. Is it a function? Yeah, it's a parabola. It's just facing the opposite way. It was flipped over, but it's still a quadratic function. The y-intercept is where the line crosses the y-axis. Y-axis is the vertical one, so it's right there at 3, so we write the ordered pair 0, 3. The x-intercepts, where the line crosses your x-axis, is at -3 and +1. So when we write them as ordered pairs, we have -3, 0, and 1, 0. So remember in those ordered pairs, for a y-intercept, x is 0. For an x-intercept, y is 0. All right, domain. So how far to the left does this line go? Infinity. How far to the right? Infinity. So our domain is negative infinity to positive infinity. Occasionally, like on the end of course test, you may also see it as that symbol, which means all real numbers. Now, like we've already said, this graph is kind of like a flipped version of the other one. So the other one opens up. This one opens down. It doesn't have a lowest point. There is no minimum because the arrows point down, which means it goes towards the negative numbers for infinity. It does have a highest point. The highest point is your vertex at -1, 4. Now, when it comes to range, remember, it's down to up. So how low does this graph go? It's got arrows pointing down, so that means it goes towards the negative numbers forever. So the highest point is right there with a y value of 4. You use the hard brackets because it stops going up right there. You use the parentheses on infinity and negative infinity because it never actually reaches infinity. It just approaches it. All right, so when is this graph increasing and when is it decreasing? You read a graph like you read the lines of a book from left to right. So starting on the left side, this graph is increasing and it stops increasing right here. Once you reach that point, it starts decreasing. So the point where it stops increasing is at -1. So it's increasing from negative infinity to 1 because we had that arrow over there. So it's decreasing from -1. Sorry, that's a -1. My apologies. So it's decreasing from -1 to positive infinity. Your intervals of increase and decrease are always using the x values. So is this discrete or is it continuous? Because it's not a bunch of dots and no line on a graph, it's continuous because all the points that make up this line, this function, are connected. All right, I left this one for you guys to do in class, so I'm going to do the same in the video, and we're going to go over this one. So the vertex for this one, same as before. It is the lowest point or the highest point. It's that turning point on your parabola. So this one is at -1, -4. The axis of symmetry, a connection we made in class is that the axis of symmetry is the same as the x value of your vertex. So it's x equals -1. All of the functions on this entire paper are quadratic. So this is a quadratic function. The y-intercept is right there where it crosses that vertical y-axis. The ordered pair for that is 0, -3. The x-intercepts are up here at -3 and +1, so we say -3, 0, and 1, 0. Now, the domain for every single one we've worked on at this point has been the exact same, and that's because without context, the domain of every quadratic function is -infinity to +infinity, or all real numbers. So the direction of this graph is it opens up because that's where it's on the open side. Does it have a maximum or a minimum? It has a minimum. It has a lowest point, and that lowest point is -1, -4. Range, how low to how high. So the lowest point is -4, and it stops there, so it gets a bracket. The highest point, we've got arrows, and up is all the positive numbers, so it's positive infinity. So when is this graph increasing and when is it decreasing? So at the very beginning of this graph, I noticed that it is going downhill from left to right. So it's decreasing. And then it hits that vertex and has that turning point and starts to increase. So it is decreasing from negative infinity, and it stops decreasing right here, which is at -1. Remember, always refer to the x-axis. So then starting at -1 and going on forever, it's increasing. And just like all the rest of these, it is continuous because the points are connected. So this next little question is asking what you notice about the function, which means the equation, and the graph. So what we talked about in class is that the x-intercepts, we have a -3 and a +1, are kind of the opposites of what we have going on here. Now, according to your formula sheet, if you have one, it says that this equation is in intercept form. So that's what we're going to write. The equation is in intercept form, which means it can help you find your x-intercepts. And the way you find your x-intercepts, the ordered pairs, we have an input of -3, gives you an output of 0. So when we look at our equation, if we plug in a -3, we should get out a 0. The way you find the intercepts in intercept form is you take each binomial, so x minus 1 and x plus 3, and you set them equal to 0. So you're figuring out what is the input that makes my output 0. So solve these like you would any other one-step equation. We add 1 on both sides, and we're left with x equals 1. The other one, subtract 3 on both sides, and x equals -3. So if you look back at your intercepts, it says x equals 1. Your x-intercept is 1, 0. So we plugged in a 1, we would get out a 0. The other way, dealing with this other binomial, x is -3. So your x-intercept is -3, 0. That's why this is in intercept form. All right, so quadratics are always U-shaped and are always functions.